Hello everyone, welcome to Function Game. And today, I am your fun man, Daniel Eating. And without further ado, let the game begins. Here is the first game, and it is called the Operations on Functions. At the end of the session, the viewers are hoped and expected to be able to identify the different formulas and enumerate methods of operations on function, perform the indicated operations of the given function, and manifest the value of patience and critical thinking skills in solving the problems. Operations of functions. Let f and g be functions. Functions can be added, subtracted, multiplied, divided, or composed with each other. There are four basic operations. Addition, which let f and g be functional, and their sum, denoted by, is the function defined by f plus g of x is equal to f of x plus g of x. Next is subtraction, wherein their difference, denoted by, is the function defined by f minus g of x is equal to f of x minus g of x. Third is multiplication, in which their product, denoted by, is the function defined by f times g of x is equal to f of x times g of x. And the division, which is their quotient, denoted by, is the function defined by f divided by g of x is equal to f of x divided by g of x, excluding the values of x where g of x is equal to 0. Now, let's have an example of how to solve the operations on functions. Given the functions of f of x that is equal to x squared minus 8x plus 16, and the second function, which is g of x, is equal to 5x minus 20. Let's proceed first in the shape of the circle. Using the formula of addition, we can be able to get the sum of the functions. So let's use the formula, which is f plus g of x is equal to f of x plus g of x. Then, we substitute the values. X squared minus 8x plus 16 plus 5x minus 20. After that, combine the like terms. Since there is only one x squared variable, we will bring it down. Then, negative 8x plus 5x, since they have both opposite signs, the answer is negative 3x. Then 16 plus negative 20, the answer is negative 4. Let's proceed to the succeeding shape, which is the triangle. Using the formula for subtractions, we can be able to get the difference of the given functions, starting off in writing the formula. Then substitute the values, x squared minus 8x plus 16 minus, then put a parenthesis before the value of g of x because we are going to change the signs of the subtrahend. We write the values of f of x, then negative times positive fx is equal to negative 5x. And negative times negative 20 is equal to positive 20. Now, combine the like terms. Which are the like terms? X squared doesn't have a similar variable. Therefore, let's copy it. Then negative 8x plus negative 5x, since they have the same sign, it is equal to negative 13x. Then, 16 plus 20, the sum is 36. Therefore, the final answer is x squared minus 13x plus 36. Moving on to the star shape. The same given, but now the operation is multiplication. Let's use the formula, which is f times g of x is equal to f of x times g of x. Now, substitute the values of the two functions. How are we going to answer this? Suppose we will use the FOIL method in order to get the product of it, starting on x squared times 5x is equal to 5x cubed. You might wonder why it is 3. In multiplication, only the constant is being multiplied while the exponents are being added. Remember, the x has a value of 1 exponent, so 2 plus 1 is equal to 3. Moving on, x squared times negative 20, the answer would be negative 20x squared. Negative 8x times positive 5x, the answer would be negative 40x squared. Then, negative 8x times negative 20, the answer would be positive 160x. 16 times 5x, the answer would be 80x. Then positive 16 times negative 20, the answer would be negative 320. Combine the like terms, and the final answer would be 5x cubed minus 60x squared plus 240x minus 320. Let's proceed to the last basic operation, which is division. Here, we are going to use the formula of division and factoring in order to get the quotient of the functions. First, write the formula. Then substitute the values. As you can see here, both numerator and denominator can be factored out. So, let's factor out first the numerator. since the given is a perfect square trinomial, it is easier for us to factor out, which the answer is x minus 4 and x minus 4. Then, in the denominator, 5x and 20 can both be factorable, and we will just divide 20 by 5. After that, now, as you can see, both denominator and numerator has x minus 4, therefore, let's cancel it out. Now, there are still remaining values, and that will be the answer, which is x minus 4 divided by 5. Oh, Yoonghee, what brings you here? Oh, it's the last but. Let f and g be functions. The composite function denoted by is defined by f composite g of x is equal to f of g of x, and g composite f of x is equal to g of f of x. In the composition of functions, we substitute an entire function into another function. Example number 1. Our f of x is x squared plus 5x plus 10, and g of x is equal to x plus 3. Find the value of f composite g of x. First, we will rewrite the formula, which is f composite g of x is equal to f of g of x. Then, we will substitute first the value of g of x into x plus 3. Now, we will substitute the values of x into x plus 3 in the x squared plus 5x plus 10. Then, simplify x plus 3, the quantity squared, through FOIL method, and the result would be x squared plus 6x plus 9. And then, multiply 5 to x, which is equal to 5x. Then 5 times 3 is equal to 15, and copy positive 10. Afterward, combine the like terms. And the final answer would be x squared plus 11x plus 34. Example number 2. Find the g composite f of x of the functions g of x, which is equal to 2x plus 6, and f of x, which is equal to x squared minus 3. Let's use the formula, which is g composite f of x is equal to g of f of x. Like the previous one, substitute the first value of f of x to x squared plus 3, and then substitute the value of g. Multiply 2 times x squared, and the answer would be 2x squared. Then 2 times negative 3 is equal to negative 6, and copy the constant. Combine the like terms, and the final answer would be 2x squared. Example number 3. Evaluate the value of f composite g of 6, wherein f of x is equal to negative 4x plus 1, and g of x is equal to 4x plus 3. First, we will write the formula first of the f composite of g of x and the substituted values. Since our x is 6, let's substitute all the x found in there with 6. Then, copy negative 4. Multiply 4 times 6, that is equal to 24. Copy positive 3 and 1. After that, bring down negative 4, then add the values inside the parenthesis, which is equal to 27, and bring down positive 1. Now, let's multiply negative 4 and 27, and the answer would be negative 108, and copy positive 1. Then, add negative 108 and positive 1, the final answer would be negative 107. Now, since we were done with the lesson, let's face the real challenge. Test number 1. Find the difference of f of x is equal to 3x plus 4 and g of x is equal to 2x minus 5. 5, 4, 3, 2, 1. And the answer is number 1. Here is the solution. The last question. Find g composite f of 2 of the functions f of x is equal to 3x squared minus 4 and g of x is equal to 2x plus 5. 5, 4, 3, 2, 1. Time is up. And the correct answer is number 3. Here is the solution. Operations and functions are rules that we follow to solve functions. Like life, there is a certain way to deal with addition, subtraction, multiplication, division, and composition of functions in order to solve the problem. As we end this session, I hope that you understand the concept of the operations and functions. That's all for this video. Thank you for watching.